thank you everyone for joining us. Today we're going to be talking about the acceleration of software development and how that's affected our ability to troubleshoot issues that arise. My name is Tali. I'll be moderating the conversation today. I am the Director of Content here at CoreLogics. CoreLogics is a real-time streaming analytics platform that enables teams to manage their observability data without needing to index it. And we are joined today, we're joined today by Oded David, who is our head of DevSecOps, and ETL Schwartz, who is a co-founder and CTO at Commodore. Oded, would you like to introduce yourself?
Hi, everybody. My name is Oded. I'm leading the DevSecOps team at CoreLogics. I'm really happy to be here. Hello.
Thank you. And ETL, would you like to introduce yourself and tell us a little bit about Commodore?
Yeah, I'll be happy to be here. So my name is ETL. I'm the CTO and co-founder of Commodore. We are the first Kubernetes troubleshooting platform. Basically, we help dev and DevOps people to understand, given an issue, given an incident, what changes happened in their system. And when I say changes, it's anything from code change to feature flag to deployment in Kubernetes. So everything in one place. This is us, and we will also show a quick demo on the end.
Great. Looking forward to that. Now, a little bit about what we're going to be covering today. We're going to be talking just a little bit about what's actually stopping teams from moving faster and delivering code more frequently. And we'll talk quite a bit about what issues are introduced as we start to move faster, and where new tools and processes come into that. Now, before we jump in, I want to just remind everybody that this is a live session. There's a Q&A box, and we will be answering questions, or I will be answering questions or bring up the questions as we go. So please do feel free to send those as they come up. Now, let's go ahead and get started. So yeah, before we talk about really like what are the issues with troubleshooting in faster paced environments, I just wanted to touch a little bit on what you guys think about what's stopping teams from moving faster. What's kind of getting in the way of that?
Yeah, so maybe I'll start. I think like there are two main obstacles in moving faster. The first one is it's not even technology, like tech-wise, it's more for culture change. People need to trust their tools, their system to move faster. And I see it a lot with like more for old-fashioned companies that used to release like once every month or once every couple of months, that when they try about releasing once per day or even once per week, they're afraid. They're like, it's going to break. I already have all of these processes in place. And once we are going to release once a day, what will happen? Everything will break and so on. So I think like culture is a very big barrier in moving faster. And even companies that are trying to do the shift don't really pay a lot of attention to like changing this specific part. Oded?
Yeah, I tend to agree. Also on that, I have to say that I see that basically boundaries are broken with everything that includes developers or any R&D in the company. It means that production becomes, any environment is basically production. The main line of thinking is that your product needs to be up and running for 24 hours, 7 days a week. On that, the need to be updated in everything, the need to help to customers as you continue to develop, the need to understand the product. You have so many new disciplines that you need to understand that basically take your time and you pay with a lot of context switch.
Yeah, I think that makes sense. What do you guys think about in terms of looking more at the technical side of things in terms of technical debt and troubleshooting in traditional environments? How does that kind of impact the situation?
Yeah, so I think it's a great point. Like troubleshooting, as I see it, it's like the silent killer. It's the thing that day by day you just spend so much time on. You don't really think about it. Like every time a developer or like a DevOps, it doesn't really matter. When he troubleshoots his system, when he's trying to understand why things doesn't work, he's not writing new features. And we see it in a lot of the companies that as they progress and they grow fast, like bigger, the amount of percentage of time they spend on like troubleshooting their system instead of writing new features is around 50% or even more. And all of this time, if they could just troubleshoot faster or write better tests or have better monitoring, can be saved. And we can take this time basically to write new features and to improve like the overall speed of the company and of the R&D team.
Yeah. That being said, there is another new aspect that basically accelerated in the last few years, especially the last few years, is the open source industry. You now use a lot of open source as part of your product. Troubleshooting is not the traditional one that I used to write a code and check it. I have 1, 2, 3, 5 people that were testing the code. Now I have open source and I need to be in line with the industry to understand the mindset, and you need better tools to be able to understand the behavior of those open source also.
Interesting. Any other last thoughts on this? Maybe, I don't know. I mean, you talked about fear, maybe, TL. Do you think that there's maybe like fear of adopting new tools that are kind of required there, or maybe, I don't know.
Yeah, I think like everything, it's fear from like new tools because I already know the old tools, and fear of doing things differently. And I think it's very obvious, like for companies that have like traditional QA, and you can't release to production without the QA like checking your code. And like obviously, if you want to release 10 times a day or like 20 times a day, you can't really have a QA in the middle. Like it doesn't make any sense. You have to automate this part, and you have to make sure that the system is always up and running and working as expected. And I think like a lot of, and I think like what Dad said earlier, like the roles has changed. And if like in the old days I was a developer and I wrote the code and I counted on the QA to catch my bugs and just stop it before it moved to production, now not only that I'm writing my code, but I also am writing the tests and I'm making sure everything passes. And if there is an issue, I'm the one who's getting awake in the middle of the night. And a lot of the people, they have their comfort zone where they just write code and that's it. And everything else is like other people's problem. And yeah, I think like it is like a very big issue in like adoption of new tools and basically moving faster.
Yeah.
Mm-hmm. Yeah, we have a question from the audience, but just before I take that, I'm curious, Oded, what your thoughts are there on in terms of what you were saying about kind of not being able to have QA and really shifting. I mean, that's a big shift in terms of the process and what people are used to. Any thoughts on that?
Yeah, so in CoreLogics, I see it in the last couple of years when you grow to become a bigger company and you basically stabilize your product and improve it. So you begin, you write a code, as Etiel said, and you test it and you see everything is okay and it's great. And then you grow and you have more people that needs to understand your line of thinking. You have more people that you expect them to work as fast as you used to work. You have more departments that needs to be, to be oriented with one another, to have understanding on what happens on the new features. So a developer is not only a developer, it becomes much more. And it's true to anyone in the organization, even customer success. Customer success suddenly need to understand the product. But this structure makes silos because I'm writing a feature. I need to be an expert on this feature because this feature also includes a lot of open source technologies. It includes documentation. It includes explaining it to customers. It includes writing even articles. It includes webinars, etc., etc. Those features are basically become another feature that are used in the industry, or basically adjust the industry to use those features. So also customer success needs to have those skills, and sales and marketing. Everybody needs to have all the skills of the organization in order to make this product alive. It makes everything works faster, but it also prevents it from moving faster. And if you don't grow into it, you basically stay behind.
Yeah, that's a bit tricky there.
Yeah.
I like this question, and it's actually going to kind of take us to the next topic. So I'll go ahead and change the slide. So the next, and this is kind of like addressing the bulk of what we're talking about here. What issues are introduced when we move faster? And a question from the audience: do you think microservices are going to increase in number, and how can devs handle that scale?
Yeah. So I think like microservices were like born out of the need to move faster, basically to allow different teams in the organization to write their own code without having the dependency of like the monolith, where one change like obviously impacts all of the monorepo and all of the monolith. So like microservice was born out of the need to move fast. And I do see the industry moving more and more like into like more microservices, trying to break things into smaller parts. And with the adoption of both Kubernetes and serverless, like we do see the trend, and I don't see it like declining anytime soon. And I think like regarding like how devs can handle that scale, I think like the next slide we are going to talk about a little bit about the tools. And I think like it's going, I try to like better explain how it's really related to microservices. So for the next one, and Oded, do you want to answer like to start with what issues are introduced when we move faster?
Yeah, sure. So you mentioned the microservices architecture. One more thing that's basically affect on this or causing these issues is the need of managing multiple production environments. You have today regulation, a GDPR, you have the EPA, PCI, etc. Your clusters, your environment changes. There isn't any meaning to a production environment. I would in the past I had one production environment, or I had one production environment that is deployed in the customer premises. Today I have 3, 4, 5. The requirement for 24/7 basically requires me to have high availability at all time, which means that I need to make sure that I have one focal point in my system. Microservices is a good example for that, because the idea behind microservices is to avoid this focal point, is to avoid this failure mechanism of one service that rules them all. The need of basically a non-agnostic metrics, because we used to think that we have a metrics that shows us issues on an environment, but now I have 5 environments. So I need to change my line of thinking on building something that is able to behave the same on multiple environments, where in each environment has different customer and different behavior. All those issues are introduced when we move faster. The ability to mitigate faster, to make the system heal or start functioning as fast as possible. SLO, SLI, a lot of concepts that were added and are needed when in order to avoid those issues or due to those issues.
So it's interesting points. Do you think then the actual troubleshooting challenges, if we're just talking strictly about troubleshooting challenges in these fast-paced environments, do you think that it's related more to the speed or more to the environment?
So it's basically a chicken and egg. We expect people to move as fast as possible because the market is changing, the market is growing, the market goes faster. So features are required. New technologies that are invented by AWS are now introduced to the public. They make me able to run faster also. But by using those technologies, by using and make my work faster and my product better, I'm basically causing new issues, new line of troubles. Multiple environments is an example of this issue because of regulation, or scale, or number of customers. All are issues that are introduced, and most of them are because we move faster. Ideally, you have something to add?
Yeah, I think you asked, Khalid, do you mind repeating your questions?
Yeah, so I'm wondering if we're looking, we talked already about what's kind of preventing us from moving fast, but if we're looking at a company that's moving fast with frequent deployments, do you think that the issues, that the troubleshooting challenges are coming more from the speed at which they're deploying, or the kind of environment that they ecosystem?
Yeah. So I think it's like each on its own, it's quite bad, but the combination of the two, it's like this is what makes things even harder, because what we need to do is to compare the old state to the new state, and once you had a very big bulk of changes that happen, I don't know, once a month, and everything was really well documented because we were waterfall, and every new feature that was going to be added was really rigorously documented. But now, because the amount of changes and the speed of changes, it's not really clear. Is it in production? Is it behind feature flag? Was it just deployed 5 minutes ago, an hour ago, a day ago? So we kind of lost track on how the system really changed. The production system became like a living organism, basically, that keep on changing really, really fast. And no one in the organization really knows what changed over the period of time. So this is regarding the speed, the speed part. And the other part, the environment, like we already said, in order to move faster, we broke the monolith to a lot of different pieces and different environments and different clouds and so on. And what happened is, again, if in the old days, all I need to do is to check one release note that was very massive. Now I need to go to each one of those small, tiny units and to understand what happened there and what changed there. So maybe I need to SSH into each machine and read the log file, or I need to somehow crack release notes over dozens of different GitHub repositories, or I need to check the logs both in AWS and in Azure and GCP. So each one of them of those issues, the speed and the complexity of the system is quite bad. But when you have a really complex system that change really rapidly, once you have an issue, and people, organization have a lot of issues nowadays, you are going to be like a detective, trying to figure out where did it change, what changed, and so on.
Mm-hmm. Yeah, absolutely. Okay, let's move on to the tools. So I'm curious, basically, obviously, with what we're all doing in CoreLogix and Commodore, we're a bit biased about the tools that are addressing these challenges. But I was hoping to get into a more of a high level view of what role do these different tools and different processes play in terms of alleviating some of the pains that have been introduced.
Okay, so from my experience, and I can tell you from CoreLogix side, in our team, we work a lot to create stability and availability. It comes when we work in Kubernetes specifically with tools that are enablers for these abilities, like CADA, which is event-driven to allow auto-scaling for our pods, horizontal pod auto-scaling. Tools like Autoscaler that allows us to automatically add nodes to the cluster, or reduce nodes to the cluster based on traffic, based on load, based on matrices that we use. Event Exporter that basically takes all the events out of Kubernetes and provide us inputs on what happened. Note problem detectors, a no termination handler to handle the pricing, the number of instances, the stability, and those all are enablers to make our products more stable. But when there is an issue, and if we go back for a second to the issue that we had before, and this is the part that I'm a bit biased, we need a way to take all the information that comes from those tools and understand what is happening in our cluster. Because if I have something like autoscaler that starts to scale up instances, then scale down, and scale up instances, and then scale down, something is happening. Now I have cost. Now I have stability issues. Now I have issues that I even didn't think of. So I need a way to be able to gather this information, to be able to troubleshoot this information, and to be able to proactively do something when something happens. And I'm sure that when Itiel will explain it, it works fine also with the system that they developed. Here come product like CoreLogix that basically takes those logs and help us to do this mitigation, to get this understanding, to add context to the problem.
Yeah. So I will say, like, I'm going to talk on Commodore like very briefly, but I will say that, like, if we look on it like from a historical standpoint, then the first thing that people really needed, like the cloud really helped like moving faster, right? But people needed a way to release faster, like in order to basically to ship their code faster. And we see like the adoption of tools such as like Kubernetes, obviously, but also Lambda functions and so on, just to make sure we can ship the code faster. Afterward, great tools like CoreLogix or Kibana in general, or Prometheus allows us to monitor this new system easily. So not only that we have Kubernetes and Lambda to ship the code faster, now we have really good open source or like hosted solutions that help us understand what is currently happening in my system. Because like we said, everything is moving fast and we need to have the right tools to make sure we stay in control while moving fast. And I would say like here at Commodore, we see ourselves like as the other missing link in this new world, basically to allow you to understand what changed in your system and by whom very easily because of the speed of changes that we currently see in the modern stack. But I will say that like it's a real issue, like releasing fast, and like even tools like Argo CD, which is another like open source tool to help you ship faster. We see how companies that are using those modern tools, those open source tools, are getting a very big increase in the velocity of the changes, and how by using like a lot of different tools from different areas, you can achieve speed that was like once unimaginable. I know that here in Commodore, we are quite a young startup, but we release like 15 times a day already. And that is because we use such like great tools to make sure everything works as expected and to make sure no matter how fast and when we will release, things doesn't really break.
Mm-hmm. That's a good segue, I would say, to a question that we have from the audience. Isn't using so many different tools just making things more difficult and complex when building fast? So maybe Itiel, you can talk a little bit about the tools and how you guys have settled on a stack that works for you.
Yeah, sure. So how did we choose like the stack that worked for us? I will say there was a lot of trial and error, to be honest. We shift quite a lot. Like I said, we're a young company. We believe in moving fast, but we change pretty much everything from like the database to our CI/CD tool. We did stay on Kubernetes, so this is the only constant over time. But other than that, we pretty much like change everything. I think that when choosing a new tool, the main issue is like to evaluate it first, to make sure it works as expected and solve a real issue for you. I will say the amount of new tools and new systems, not even if you like do the right choices. And for example, I really think that we did a lot of like good choices that allows us to move faster. It is hard to manage everything, and going into like 10 or like 15 different tools once you have an issue, it is a real problem, and we do see it a lot with our customers. Basically, it's one of the things that Commodore helps you with. But it is an issue, and even like I think the ecosystem now is like, it looks like it's flooded with new tools. Once you use all of those tools, you're just like tired of like jumping between tabs, trying to scrape like the relevant data from each and every one of them. Odette, did you want maybe to add? Or?
Can you repeat so we can make it?
Yeah, so the question was, isn't using so many different tools just making things more difficult and complex when building fast? So if you could just talk a little bit about maybe how you've chosen tools that work for your team.
Okay, so it's an interesting question because basically, when you go to Kubernetes, you see that you have, and we are heavy users of Kubernetes. All of our infrastructure is Kubernetes. We run all our data stores, all our services on Kubernetes. And when you start to manage this kind of system that requires, from one side, it gives you a lot and helps you, but from the other side, has a lot of needs. Like a child, it needs a lot of things. Then you start using open source. You say either I will invent the wheel, which in most cases is not needed, or I use an existing tools. And you start with one tool and you say, oh, it's great, and then it becomes 2, 3, 4, 5, 7, 20. Today we ran over 60 different services on Kubernetes that are not related directly to our product. They give us all the infrastructure and management that we need, but it's not related directly to CoreLogics as a product. Without it, CoreLogics probably won't be able to hold the current scale, but it's not part of the development that is happening in-house. Add to this all the needs of opening PR and adding everything that you need to the existing product, it makes a lot of issues, but I don't see a way that you won't or will not use those tools. So it's really interesting.
So maybe it's, finding a good way to connect them or just make the usage as streamlined as possible. Even if you do need to add, so maybe like the answer is don't be afraid of adding new tools, but figure out a way to make them work for you.
Yeah. You start from a line of thinking of I'm going to monitor them. When you understand how you're going to observe or monitor the system, then you know that you can use the tool at least in production environments.
Great. I think we can move on. We're going to be looking at, one second. Yeah, we're going to be looking at a sample troubleshooting flow, and it's actually, I think, a really nice segue to the topic because we're going to be looking at how CoreLogics and Commodore can work together without causing a lot of headaches, basically, or making anything more difficult or complex. So before I pass it on to Odette to kind of take over and we'll look directly in the CoreLogics platform. And I'll just go quickly through the flow. So when an event occurs, an alert is triggered by CoreLogics, and the alert is sent to the Slack bot. And from the Slack bot, we can open the Commodore platform directly from the alert and easily drill down to find the root cause and quickly resolve the issue and keep moving, right? That's the idea. So Odette, take it away.
Sure. So I'll share with you CoreLogics product pretty quickly. So as we discussed, we have a lot of events coming to our system, and on a daily basis we get around few millions of logs from all of our environments. It's worth around 1 tera of data. Starting to run over it manually, it's basically impossible. So what we have is a system basically that allows us to collect all those logs, aggregate them, do proactive action based on changes that are happening in the system. So let's take a scenario that is fit with our friends from Commodore. We basically create, we get a lot of events to our system. We are creating an alert. This alert basically is for one of our services, the REST API. The idea behind it is that once a specific log appears, it basically sends a critical alert to Commodore. And we did a preparation in the beginning. We collected the logs. We have an alert. The alert is jumping. And when the alert jumps, basically gets to Commodore. And from there, ETL will continue to demonstrate the solution.
Okay, great. Thank you very much for that. So I'm going to do like a very I'll continue with your flow. So this is the Commodore platform. To all of you who don't know Commodore, Commodore, like I said, is a Kubernetes native troubleshooting platform. Basically, we collect all of the changes of the alert from your system and allows you to get a glance of both like the higher level, what is currently happening in my system, but also for each service, we build a comprehensive timeline, including all of the changes, alerts, config changes, and so on, all in one place. So like Oded said, in this example, we had an issue with the REST API. Basically, one of the services in our system, I can see that it's currently have like 1 out of 1 replica. I can see the full history for the last 24 hours for this service. And using Commodore, I can see everything that changed in this particular service over time. So I'm going to click on like an example of like a deploy event, and I can see everything they change, both from the Kubernetes side. Basically, I can see that the image change in this deployment, and I can expand it and basically to see all of the change. But more than that, Commodores know to match different tools into the same screen, into the same context. So I can know what was the GitHub changes that happened in these specific deployments. So now let me go like over time, and I can see that there was a deployment after deployment, and each of them changed something in the image. And okay, removing unused code, sounds good. And the last deployment didn't really change any image. The only thing that changed is the replica count. It changed from 5 into 1. Basically, I can again like do a zoom in and see that this is what changed. And right after this change, what happened is 2 things. One of them is a health issue, and I can zoom in here and see basically that the new pod is having like out of memory, or like the only pod that left is having out of memory. And I can also see the alert that I got from CoreLogics that helped me identify the issue, and basically tells me that the service REST API has too many unavailable replicas at the moment. So the idea behind Commodore is to take all of this data from different tools into one place and to give our users a very simple way of looking at things, basically to troubleshoot without the need necessarily like to open each and every of those tools, but only go there when needed. Like when, for example, when you need to view the logs, you can go to CoreLogics directly and view them and troubleshoot like the app level. So that's pretty much about it. I will show just the Explore services, which is Commodore way of like viewing not only a specific service, but all of the cluster, basically all of the services and your current healthiness status. So yeah, that's pretty much about us.
So just to clarify on the workflow here, so once the alert is set up, and that would just be like a one-time thing, right, Oded? Like once the alert is set up, the user wouldn't need to open both platforms.
No.
Then it would be like a really easy, links always available, not like, yeah, okay.
Yeah, no need for like a lot of, or any like manual work, only like configure it once and it just works.
Mm-hmm. Awesome. Okay, yeah, question. How does Slack come into play? It's a good question.
So,
Yeah.
sorry.
No, go for it. Sorry.
Cool. So I can tell you that for us, Slack is really important for our day-to-day. The concept of Slack is basically using channels or being online all time. But other than that, it has a bunch of integration. Take, for example, CoreLogics. So in our scenarios, we are able to create events directly from Slack to CoreLogics, which help us and or allows us to see manual changes that happen in real time as part of the flow of data. We are using it to get basically pop-ups on things that happen on our production, on our deployment process, etc., etc. Basically, as I see it, Slack today is an interface or another extension of any tool that is being used, either CoreLogic, Commodore, or any other tool in this department. And Tell if you have something to add, feel free.
So, sorry. Sorry,
no, go for it. Sorry.
Before I'll hand it off to you, Itia. So, Oded, you're saying that actually the connection between Slack and CoreLogics is going in both directions. Is that correct? So you're sending alert data to Slack, but we're also able to ingest that data and kind of incorporate it to add more context to the more traditional. Okay.
Yeah, I will say that like one of the cool things that we see in Commodore is that because Slack is so strong, and obviously Commodore has a great integration also with Slack. We have a Slack bot, and you can send alerts from like Commodore to Slack as well. The very cool thing is the ability to troubleshoot or to get a very good glance on what is currently happening in your system using Slack. So basically, because everything is being sent into Slack, if it's like a release notes from Commodore or alerts from CoreLogics, you can get a good glimpse without opening any other tool, basically only the tool that is already open, which is Slack, and you can understand what is currently happening in your system. I will say that our product also try to enrich existing alerts over Slack, basically, but giving our users all of the context they need to troubleshoot efficiently. And this context might be you had this in this deployment, or you open this feature flag and this configuration flag. But also, FYI, you have those alerts from CoreLogics and those changes in this specific area of your system. So pay attention to that when you try to troubleshoot.
Awesome.
Yeah.
Great. Do you have any other questions from the audience? We'll kind of hang out for a few more minutes. Let some of those maybe lingering questions come out.
I can say if I have like a minute while people are thinking about questions, I think one of the biggest things that we see in organization today is that some people in the organization have become like the knowledge hub of the organization. Basically, they are the bottleneck. They are the only one in the organization who knows how to use all of these different tools and to troubleshoot in using those tools. What we try really hard is to liberate this knowledge, basically to take the data from all of these different tools and to showcase it very easily in order to free up the bottlenecks, which are basically the most busy people inside the organization. A lot of the times it's the DevOps or like the DevSecOps, and to liberate their knowledge and the things that only they know how to do at the moment. And like using Commodore, every developer can be just as good or at least very similar to an expert DevOps, and to get all of the data, all of the context they need in a couple of like minutes instead of asking Oded every time, like, do you know why my system is down?
Right. Yeah. Okay, yeah, did have a couple of questions come in. The first one is for you, ETL. How does the onboarding of Commodore look like, and does it replace APMs?
Yeah, so we don't replace APMs. We work like perfectly with existing tools and APMs, if it's like CoreLogics, Datadog, and Relic, and so on. And the onboarding experience is very easy. Basically, install a Kubernetes agent, which is one pod per cluster, integrate with the Commodore platform, and we usually give value and see like the first value to our users in a couple of minutes. So a couple of minutes from installation, you have this tool that already track everything that happens inside the cluster and notify you when we have issues.
Awesome. Oded, I would like you to also go into a little bit of the integration and the setup with CoreLogics, and then I have a follow-up question. You can just kind of flow into it. Are there any events in the system that don't trigger an alert or that become invisible using traditional monitoring tools? Oded?
So basically, triggering an alert is something that is based on the company knowledge or the people in the company. There are some cases that you want an alert to jump on or to trigger up based on an event that is happening on the system. But these abilities are either reflected in CoreLogics automatically by some kind of AI that we provide, or by people manual knowledge. There are cases that I would not like to trigger someone at night if there is an issue. I can wait for the next day. There are cases that I would like to know about something that is happening, but I wouldn't consider it as an alert. Cost exhaustion or some kind of change in the system that might be reasonable. So there are cases that alerts are not being triggered. Most of the cases are decided manually by the team or by the company.
What are your thoughts also in terms of, I mean, if we're talking about traditional monitoring tools and looking at the amount of data being generated by these modern applications and systems, can you talk a little bit about in terms of, I mean, events will be invisible if the data isn't being analyzed, right?
Yeah. So the cool thing about CoreLogic system and probably about ETL system is the fact that we have an endless number of integrations, which means that you can take any part of your organization and basically integrate it to CoreLogics. And if we looked on the traditional system and we consider logs as logs, today we consider them as an event, and an event as more power. An event is something that can be driven. It can affect my system. As in CoreLogics, the cool thing is that as you add integration to the system, you get more visibility, you get more observability, you get the ability to create more proactive actions that are meaningful to customers, meaningful for us. I can tell you that by using our system, we basically stabilized our own product. We're basically dogfooding ourselves, which is pretty cool.
Yeah, that is. There's a lot of inception, chicken and egg concepts going on in this discussion. Great, and in terms of the setup and all the integrations that you mentioned.
So in CoreLogics, you basically open an account. An account is a username and password or email in our case. And once you open an account, you have a CoreLogics account, and you just start sending data. It's transparent. It's simple. It's something that is done almost automatically for you. You just need to send data or decide which data you want to send, and by sending this data, we take this data, we run it through, we enrich it, we help you get better decisions.